The history of math is our intellectual foundation to understanding science. Science. Beautiful, awesome, wonderful science. It's the creative foundation to our ineffable future. Hi, I'm Gabrielle Birchak, and this is my podcast, Math, Science, History. Being a resident of Los Angeles, I often find myself stuck in traffic, and believe it or not, I really do love traffic. As a bookaholic, it gives me the chance to listen to my books on Audible. Did you know that when you sign up at Audible, you get a free audiobook download and a 30-day free trial? You can sign up at www.audibletrial.com/mathsciencehistory and choose from over 180,000 titles for your iPhone, Android, Kindle, or MP3 player. So many wonderful books to explore the wonders of math, science, and history. As we approach 2020, the developments we make in machine learning, deep learning, and artificial intelligence are extraordinary. It is exciting to get caught up in how this niche of the computer world benefits us and advances us in science and technology. On October 19th of this year, I had the opportunity to attend a lecture at the Getty Villa Museum in Malibu. At the lecture, I had another epiphany about artificial intelligence that gave me a whole new appreciation for this science of big data. Of all of the 840 museums and art galleries in my hometown of Los Angeles, my favorite museum is the Getty Villa. It's nestled near the shoreline of Malibu, and it's dedicated to the study of arts and cultures of ancient Rome and ancient Greece. I'm currently writing a book, as some of you know, about ancient Rome, and so I find myself there often, and it really does feel like a second home. The Getty Villa is a recreation of the Herculaneum private residence, now referred to as Villa de Papyri, once owned by Julius Caesar's father-in-law, Lucius Calpurnius Piso Caesonius. What a long name. It is referred to as the Villa de Papyri because the house contained a library filled with papyrus scrolls. Today, Herculaneum is a beautiful little town located on the Bay of Naples on the southwestern side of Italy. Herculaneum's first known inhabitants included Sabini tribes from the 6th century BCE who spoke Oscan. By the 4th century BCE, the ancient Italic Samnites inhabited Herculaneum. Eventually, the area fell under Rome's control around 200 BCE. On October 17th, 79 CE, our current era, Mount Vesuvius erupted, violently gushing forth a deadly cloud of gases that reached a height of 21 miles in the air. It was not just a cloud. The volcano savagely emitted rock fragments, pumice, hot ash, gases, and particles from within the mountain. On my website, I have posted an illustrated video that really does a great job of recreating the damage to Pompeii during the eruption. Though the eruption of Mount Vesuvius is often associated with Pompeii, the damage it created was really far-reaching. The explosion of Mount Vesuvius covered Herculaneum with 30 meters of ash. The eruption was so massive that it lasted between 18 and 20 hours. For perspective, the eruptions of Mount Vesuvius released 100,000 times the thermal energy of the Hiroshima-Nagasaki bombings. It's really hard to believe that any humans survived the initial eruption of Mount Vesuvius. However, they did survive, including Pliny the Younger, who was a historian, lawyer, and Roman magistrate. I personally am really grateful for all of the writings that Pliny wrote about this explosion because his works validated the discovery of Herculaneum in 1752 when excavators commissioned by the French royal family were digging for wells in that area. The French royal family then commissioned archaeologists who stepped in and began their excavation. There, in the villa, archaeologists unearthed an area that was void of oxygen when the volcano erupted. So, in the oxygen-deprived area, these archaeologists found almost 1,800 carbonized scrolls. This revelation was interesting because before discovering that they were scrolls, many excavators thought that they were just charred tree branches, and they just threw them away, sadly, out of unknowing ignorance. The talk at the Getty Villa was fascinating. Classicists Dr. David Blank from UCLA and Dr. Richard Janko from the University of Michigan discussed the efforts that they took to read the layers of papyri, and Dr. Brent Seals of the University of Kentucky discussed how he used advancements in artificial intelligence and MRI imaging to completely virtually unwrap the scrolls and read them. The Getty Museum live streamed the program, which I have posted on my blog at mathsciencehistory.com. Though the eruption of Mount Vesuvius in 79 CE was immensely destructive, this powerful act of nature ultimately preserved the history of Herculaneum. However, the challenge at hand was how to read them. The volcanic ash and gases carbonized the scrolls, which made it impossible to unroll them and see what was written inside the papyri, because archaeologists and scientists couldn't unravel them. And so this began hundreds of years of attempts to read what was inside the scrolls. In 1752, King Charles VII of Naples commissioned the study of these scrolls and hired curator Camillo Paderni to commence work on them. Paderni sliced the rolls in half and carefully removed the layers to copy the readable text. The problem with this method is that it destroyed the scrolls. So, in 1756, a Vatican priest named Antonio Piaggio, who was also a conservator of ancient manuscripts at the Vatican Library, he created an invention that would unroll the scrolls 5 millimeters a day. This machine is called the Piaggio Machine, and it was the first successful apparatus to unroll the treasured scrolls to see what was inside the papyrus. The first scroll took 4 years to unroll. But once Piaggio and his team unrolled it, they quickly copied the text before the scroll decayed. Again, this process would have been perfect had it not destroyed the scrolls. Unfortunately, the process of reading the scrolls involved breaking them. This unfortunate destruction continued for over 250 years until 1999, when a team from Brigham Young University, led by Dr. Susan Bourras and Dr. Steve Bourras, began using ultraviolet light to read the scrolls using technology that NASA had developed to view distant and dark planets. This method proved to be very useful, and by June 4th, 2011, 1,600 Herculaneum papyri had been digitized. By 2007, Seals' team from Kentucky, along with the Institut de Papyrology, began analyzing the scrolls with X-rays and nuclear magnetic resonance. 2 years later, the Institute of France, along with the French National Center for Scientific Research, imaged 2 Herculaneum papyri with microcomputed tomography in order to read inside the scrolls. By doing this, the teams were able to estimate that the scrolls were between 36 and 49 feet long, a little less than the length of a bowling lane. Using microcomputed tomography in 2009, Seals headed up a team where they virtually unwrapped scrolls using 3D scans. This was the first radiograph of papyri. They had created a way to unwrap the scrolls virtually and collect the data from inside of these ancient papyri. From that point, reading and understanding the scrolls became a process of acquisition, segmentation, texturing, flattening, merging, and visualization, and scholarship. The papyri no longer needed to be opened and destroyed. By 2015, they were virtually unwrapping the scrolls. The process began with acquiring the three-dimensional scan of the deformed manuscript. This three-dimensional process included obtaining a scan of a set of cross-sectional images of the internal part of the scroll. As a three-dimensional scroll, the viewer could then see layers of the scrolls. However, the viewer still couldn't see the text. In order to see the text, they carried out the virtual unwrapping. The virtual unwrapping used a process called segmentation. In this process, the software would move through the scroll and trace the shape of a single scroll wrap. The three-dimensional model would produce a flat segment of the scroll. Then, using the segmented portions, they implemented the next step called texturing, which would extract the ink from the data. That included running another pass through the scroll looking for bright pixels. The bright pixels represented dense material on the scroll, which indicated traces of ink consisting of iron or lead. However, because the papyri was curved, they then had to flatten the image. They repeated this process of segmentation, texturing, and flattening multiple times on one small section of the scroll. These processes of steps created multiple segments of the papyri, which could then be pieced together like a puzzle. Once they placed the segments together, they would merge them, creating one combined image that showed the full text. Then, using this process to gather the text, it created what seals referred to as word soup. It became the perfect resource for gathering metadata and confirming the text. With this metadata, they were able to use artificial intelligence and machine learning to predict what the writing was on the scrolls. Now, without cutting up the papyri, they could see the internal structure of the scrolls. Some of these scrolls go back as far as the 4th and 3rd century BCE, with many of them written by Epicurus. The discovery of the written word from thousands of years ago is fascinating, thought-provoking, and even funny. Janko, in his presentation, talked about one particular scroll written by Zeno of Sidon, which was titled In Reply to Craterius's Essay Against Zeno's Essay on Geometric Proofs. Janko referred to this as the oldest known reply to a hostile book review. So there you have it. We now have the oldest known reply to a hostile book review. Though there were several pieces of scientific and mathematical works, the majority of the collection is by Philodemus of Gadara, who was an Epicurean philosopher. Finally, after 2,000 years, we can use our advancements in technology to peek into the past. In my opinion, when seals saw the text as depicted through machine learning, it made the last 2,000 years seem like a tiny speck of time in the grand scale of our histories. It was a moment when our most momentous histories converged with our most valued technologies. The past converged with the future. It was a moment that our world became that much more enlightened by the insight of our ancient philosophers and the brilliance of our current scientists. Across the span of 2,000 years, two separate teams of brilliant-minded individuals came together and opened up a new understanding of human nature, scholarship, philosophy, and mathematics. That is the power of history, and that is the power of science. I'm Gabrielle Birchak. This podcast has been brought to you by caffeine. Delicious, wonderful nectar of the gods caffeine. Coffee, tea, coffee candy, you name it. I love it. Thank you for listening to Math Science History. If you are interested in reading more about the history of math and science, please come visit me at mathsciencehistory.com. And while you are there, if you like what you're listening to, please feel free to click on that coffee button and buy me a cup of coffee. Until next week, carpe diem.